Hi guys, it's me again, Angie, and welcome to another video. So for today's video, I'm going to answer the inside activities in chapter 7. But before that, I'm going to open first my NetAcad. So let's see the activities here in the course index. So the first activity is a binary to decimal conversion. This activity allows you to practice 8-bit binary to decimal conversion as much as necessary. We can recommend that you work with this tool until you are able to do the conversion without error. Convert the binary number shown in the octet to its decimal value. So as you can see, there are position here and the bit. So we will add those position with 1 bit. So 1 plus 2 plus 32. 1 plus 2 plus 32 equals 35. So we will type here in the decimal value 35. Let's check. The decimal value you have entered is correct. Please check. Please click new number to continue. Let's try another one. 1, 2, and 128. 1 plus 2 plus 128 equals 131. Let's check. The decimal value you have entered is correct. Then, the next, we will go again to the course index. Then, the next activity is decimal to binary conversion utility. This activity allows you to practice decimal conversion to 8-bit binary values. We recommend that you work with this tool until you are able to do the conversions without error. Convert the decimal number shown in the decimal value row to its binary bits. So this is the contrast of binary to decimal. There is a given decimal value, position, and the one that we will type here is the bit. So there is 241 decimal value. So we will think of a number. 128 plus 64. 192 plus 32. 224 plus 16. 240. Then there's only one missing, so plus 1. So we will put 1 bit to those numbers. And 1. Then the others is 0. Let's check. The binary values you have entered for all positions are correct. Please click new number to continue. Let's try again another one. So 64 plus 32 equals 96. 64 plus 16. 48. 16 plus 32. 64 plus 4. 32 plus 16 plus 8 plus 4 1 plus 2 plus 4 1 plus 1 plus 2 plus 4 plus 8 plus 16 plus 32 63 plus 64. Then the next activity, 7.1.2.4. Determine the network address. Use the ANDing process to determine the network address in binary and decimal formats. Let's try this. 165. One 72. The binary and decimal versions of the network address are correct. Then, let's go back to the course index. The next is 7.1.3.7. Click Start to view the destination IP address. Next, click the host, which will receive a packet based on the address type, unicast, broadcast, or multicast. This is a timed activity. You have successfully identified the transmission type. Then, the next is public or private Internet Protocol version 4 addresses. So, instructions. Drag each IP address to the correct category, public or private. So, public. Then the others is private. Then you have correctly identified all the IP addresses. So what is a public IP address? A public IP address is the address that is assigned to a computing device to allow direct access over the internet. A web server, email server, and any server device directly accessible from the internet are candidates for the public IP address. A public IP address is globally unique and can only be assigned to a unique device. So, what is a private IP address? A private IP address is the address space allocated by Internet NIC to allow organizations to create their own private network. There are 3 IP blocks. These are Class A, B, and C, reserved for a private use. The computers, tablets, and smartphones sitting behind your home and the personal computers within an organization are usually assigned private IP addresses. A network printer residing in your home is assigned a private address so that only your family can print to your local computer. So let's go back to the course index. So the next activity is Internet Protocol version 4 issues and solutions. Drag the IPv4 and IPv6 terms to the field next to the appropriate description. So my answer here in the first is IPv6, then IPv4, then transports an IPv6 packet over IPv4 networks, tunneling, uses an 8064 to convert between IPv6 and IPv4. Then the last is allows IPv4 and IPv6 to coexist on the same network segment. So you have successfully matched the IPv4 and IPv6 terms to their descriptions. Internet Protocol version 6 is a network layer protocol of protocol that enables data communications over a packet switch network. Packet switching involves the sending and receiving of data in packets between two nodes in a network. It is the most recent version of the Internet Protocol. Internet Engineer Task Force initiated it early 1994. The design and development of the suite is now called IPv6. Then, for IPv4, Internet Protocol version 4 is a technical standard used to define a single unique IP address on a network, and IPv4 is expressed as four numbers separated by periods. So, what is an IPv4? It was deployed for production in the ARPANET in 1983. Today is the most widely used IP version. It is used to identify devices on the network using an addressing system. The IPv4 uses a 32-bit address scheme allowing to store 2 raised to 32 addresses, which is more than 4 billion addresses. Then tunneling. Tunneling is a protocol that allows for the secure movement of data from one network to another. Tunneling involves allowing private network communications to be sent across a public network such as the internet through a process called encapsulation. The encapsulation process allows for data packets to appear as true they are of a public nature to a public network when they are actually private data packets, allowing them to pass through unnoticed. Then the next one is translation. Network address translation, or the NAT, is the process where a network device, usually a firewall, assigns a public address to a computer inside a private network. The main use of NAT is to limit the number of public IP addresses an organization or company must use for both economy and security purposes. So the last one is the dual stack network. It is a network in which all the nodes are both Internet Protocol version 4 and Internet Protocol version 6 enabled. This is especially important at the router, as the router is typically the first node on a given network to receive traffic from outside of the network. Then we will go back to the course index. So the last activity is identifying IP protocol version 6 addresses. Point 3. Drag the IPv6 address type to the most appropriate description. Unique Internet Routable IPv6 address, dynamic or static. FEAT is to 1. Typical IPv6 prefix used to indicate the network portion of the address. And lastly, used to communicate with other devices on the same IPv6 subnet. This is because global unicast address is similar to a public IPv4 address. These are globally unique internet routable addresses. Global unicast addresses can be configured statically or assigned dynamically. Linked local addresses are used to communicate with other devices on the same local link. With IPv6, the term link refers to a subnet. Linked local addresses are confined to a single link. Their uniqueness must only be confirmed on the link because they are not routable beyond the link. In other words, routers will not forward packets with a link local surface or destination address. Then the /64 is the prefix length. It is the number of bits in the address that is fixed. So 64 indicates that the first 64 bits of the 128-bit IPv6 address are fixed. The remaining bits, or the 64 in this case, are flexible and you can use all of them. So that is all for today. Thank you for watching and see you on my next video. Bye!